Hello, boys and girls. Today we're going to do lesson 3.2, graphing linear equations. So it seems like a good place to start is by talking about what is a linear equation and what is not a linear equation. So just by the words, we can probably figure out that a linear equation is an equation that makes a straight line, which means a nonlinear equation would thus be an equation that does not make a straight line when it's graphed. So that all probably makes pretty good sense to you guys, and you guys are a smart group. So if a line was actually graphed, I'm sure all of you could tell if it was linear or not, because if it was linear, it would look like this, and if it was nonlinear, it might look something like this. But what happens if we're just looking at the equation? How can we tell by looking at an equation if it's linear or not? Well, if you look at your guided notes, it actually tells you the variables in the equation, if it's linear, have an exponent of 1. And nonlinear equations have exponents on the variable that are greater than 1. So let's look at our guided notes, and let's look at a few examples. The first one says 3x squared minus 3x plus 4 equals y. Well, let me write this down. That 3x squared has an exponent that is greater than 1, so it would go right here. So 3x squared minus 3x plus 4 equals y is nonlinear because of this. And if we look at the next one says x plus y equals 7. There are no exponents on the variables, which means the exponents are actually 1, so this would be linear. The next one has a fraction in it, and a lot of times we think fractions make things completely different, but they absolutely do not. This next one, 1/2 x plus 12 equals y, that is also linear because there's no exponent on it, so that would go right here. And finally, the last one would also be nonlinear because of that exponent of the 3 on the x, so y equals x cubed. So if you were to graph either of these top ones, if you were to graph either of these, they would make a straight line. Those both would look something like this. But if you were to graph either of these, they're not going to make a straight line. They're going to, actually, I'll show you what they'll look like. The first one would actually be a parabola, so it would look something like this. And the second one, since it has this cube, that actually means that it goes in 3 directions, so it would look something like this. Both of these items we won't talk about for quite some time, but you just need to know because of these exponents, this exponent right here and this exponent right here makes them nonlinear. That's what you need to know for the first example. So you can pause this video, and you should pause this video and go do practice problems 1 through 4. You should get done with those very quickly, and then you can come back to the video. And so at this point, you should be on homework problem number 5. And so let's go ahead and do an example that should help you with homework problem number 5. So in your guided notes on example number 2, this goes right along with homework problem number 5. And what we're going to do is it gives us an equation. Our equation is right here. It's going to give you an equation, and we need to find 3 ordered pair solutions by completing this table. And then once we do that, we're going to choose 2 of them, and we're going to use those to graph. So most of today's lesson will be all about 2 words, substituting and solving, which we learned how to do in lesson 3.1. So let's go ahead and do this. Let's write our equation down. We've got x minus y equals 6. Remember, they're going to give you clues. We'll look at the table. The first clue we're given is y equals 0. So again, we're going to substitute and we're going to solve. So we still don't know what x is, so we've got x minus 0 equals 6. Now just a little shortcut, x minus 0 isn't going to change anything because anything minus 0 is itself. So we get a little shortcut on this one, and we can actually just mark this out. And believe it or not, we're done with the first one. X equals 6. So we can put 6 here. And as we talked about the other day, each one of these rows in our table is an ordered pair. So we've got our first ordered pair, 6, 0. So let's do the next one. I'll change colors. I'll draw a line here. Let's do our next one. Same equation. X minus y equals 6. This time it tells us that x equals 1. So our clue is x equals 1. So 1 minus y equals 6. And we will do inverse operations. We will go minus 1. Minus 1. Let's talk about this real quick before we go further, because this is a common place that students make mistakes. A lot of times students add 1 because they see this subtraction and they think, oh, I'm supposed to add. But we have to realize that this negative goes with the y. This is a positive 1, which means we need to subtract. So these cancel out and we're left with negative y equals 5. And our last step, just a shortcut, if you're ever left with negative y or negative x, you can simply take this negative and you can move it over here. That's just a shortcut. So our final answer is y equals negative 5. So there we go. Let's use it to write an ordered pair. We've got 1, negative 5. And finally, we would do the last one, which I'm going to roll through this pretty quick because we've already done 2, but our clue is y is negative 2. So we've got x minus, now be careful, that minus is part of this minus right here is part of the problem. We still have to put this negative in with it. So we've got negative 2 equals 6. X equals, let's rewrite this. Minus negative cancels out and makes a positive, so we've got plus 2 equals 6. Since it's an addition problem, we'll go minus 2, minus 2. These cancel. X equals 4. There we go. So we've got our 4 ordered pairs. There we go. So you have this written down. I'm going to go to our next, and I'm going to bring in our coordinate plane. So you guys have this coordinate plane, and you guys also have your ordered pairs. So you can choose whichever ones you want. It does not matter. I'm going to use the first one, which is 6, 0. So we go over 6, we go up 0, so there's our first point right there. For our second point, I'm going to choose to just use the second point on our table, which is going to be positive 1 and negative 5. Our first number is our x, so I go over to 1 on the x-axis, and then I go down to negative 5, which means our second point would be right there. And we simply connect the 2 points. It is a line, so make sure you put arrows on the end of it, and there you go. So, quick pointers when it comes to using MyMathLab. When you go to plot a point, there will be a box below the graph, and there will be a couple tools. There will be an arrow, and then right next to the arrow there will be a it's called a line tool, and if you put your cursor on it, it'll actually say line tool. So you click on that, and then you just take it to your first point, you click, and then you take it to your second point and you click, and that's all there is to it. I will give you one or two more pointers. One, go very slow. It sometimes is very easy to mess up. My second pointer, and this is a big one, at the top right hand corner of your graph, there's a little magnifying glass. I would recommend clicking it once to make your graph bigger. The bigger your graph is, the easier it is to get the correct points. A lot of times people do not click that magnifying glass and they mess up because it's much harder to plot these points on a small graph. So those are just a little helpful hints to doing this on MyMathLab. So now that we've went through this final example, you should be able to pause this video and you should be able to go to your homework and you should be able to do homework problems number 5 through 6 now. So go ahead and pause this video. Go ahead and do a couple more homework problems, and when you're done with number 6 you will need to come back because we're doing something slightly different from homework problems number 7 through 11. So come on back after homework problem 6. Okay, now we're going to do problem number 3 on our guided notes, and problem number 3 goes with homework problem number 7. So they look a lot alike. So here we go. Let's go ahead and just put example 3, and you already have this written down, so you won't have to do this. And the problem we'll be working is x minus 2y equals 6. Now, you don't have a ton of room to work this on your guided notes, but you will have a little bit of room above your graph, so you'll have to just write this kind of small. The way we're going to do this is we're going to make a table. We're going to make a table just like we did on the previous example. Only difference is we have to make our own table. So let's just make it as simple as possible. Let's just do this. Let's just make a little table like this. We'll put an X, put a Y, and we'll give ourselves 3 columns here. And I'll erase this. There we go. And you do have enough room to do this above your graph, and you do need to work this in your graph. If you don't have enough room, you can use a separate sheet of paper. So here's what we're going to do. Some of you might be saying, well, on lesson 3.1 and the last example on 3.2, they gave us some numbers. They gave us some clues. Well, you don't get that this time, but that's okay because you get to pick your own clues. What we're going to do is we're going to choose numbers for x or for y, and we're going to solve it. Now I'm going to give you a helpful hint. So those of you that are listening to this video and paying attention, you'll get a helpful hint right here. Since y has a coefficient, it's going to be easier to pick numbers for y. You don't have to. You can pick numbers for x, but since y has a coefficient, it might be easier to pick numbers for y. So some of you guys might be saying, well, what numbers do we pick? And the answer is it doesn't matter. It really doesn't. Now, I would pick small numbers, so let's go with this. Let's just go with 0, 1, and 2. You're going to be working the problem, so why not pick the easiest numbers? But again, you can pick anything, and you could have actually picked numbers for x. We could have picked 1, 2, and 3 here if we wanted to. The only reason I chose y is because y has a coefficient, and I feel like it'll be easier. So here we go. We're going to pick some numbers for y. We're going to use 0 because 0 is always the easiest. We're going to pick 1 because that's pretty easy too. And we're going to pick 2. So now that we have this, now that we've chosen these numbers, it's just like all the other problems. 2 words, substitute, solve. Let's go. Here's our first one. X, we don't know it, minus 2. We said y is going to be 0 equals 6. Line down the center. X, it's a horrible X. Let's erase, try again. X minus 2 times 0 is 0 equals 6. This is nothing. X equals 6. You just got your first ordered pair. Your first ordered pair is 0, 6. Look how easy that was. You just got to pick your own y, whatever you wanted, and we substitute and solve. Let's do one more problem. This time we're going to go with 1. Again, we don't know x. Minus 2 times 1 equals 6. X minus 2 times 1 is 2 equals 6. It's a subtraction problem, so we are going to go plus 2 and plus. Try this again. Plus 2. X equals 8. And we have it. And we have our second ordered pair. And this is enough to graph. So let me do something real quick. You don't have to write this down, but let me show you this real quick. Let me show you why this problem was easier to picking a number for y. And we did it again because y had the coefficient. But if you picked something for x, let me just show you why it might not have been quite as easy. Let's just pick a random number. Let's put it in green. Let's just pick a random number. Let's say, hey, 7's my lucky number. What happens if we make x 7? We can still do it, but we might get a messy number. So watch what happens. If I make x 7 minus 2 times y equals 6, it's just a little bit harder of a problem. So I would go minus 7, negative 2y equals negative 1. Divide by negative 2, divide by negative 2, y equals 1/2. Now, a couple things here. One, it took us an extra step. It was a two-part problem. We didn't have a two-step problem over here. Notice, this was very easy. And we just had a one-step problem here. We just had to add 2 to both sides. This was a two-step problem. We had to subtract 7, and then we had to divide by negative 2. Another thing was, look what we ended up with. We ended up with a fraction. We ended up with 1/2, which isn't a big deal, but if you're going to graph it on MyMathLab, then it might be a little bit more challenging. So again, just a tip. If y has a coefficient, it might be easier to choose y. So I'm not going to take up a lot more of your time with this one. I am going to graph it real quick. We'll go to the next slide and we'll pull in a graph. And our points were 6, 0, and 8, 1. 6, 0 is there. 8, 1 is there. And we can connect these with a line, and we're finished. Let's do one more quick example before I send you off to your homework. This one will be quicker, and this is like homework problem number 8. The equation on this one is x equals 4. Again, for all of these today, all of them, we're going to use a table. So I'll put our table right here, x and y. Now, if you'll recall, and this is probably the most important thing today, you get the choice, you get a pick. But on problems like this problem, and again, this goes with homework problem 8 and homework problem 9, you don't get to choose, not a lot. Because this tells you, this is a unique problem because it tells you Look what it says. X equals 4. Again, x equals 4. So that means we don't have a choice. X equals 4. So that has to be 4. And this has to be 4. And this last one has to be 4 as well. They all have to be 4 because this says x equals 4. Let's say, for instance, just for the sake of saying it, let's say the problem was y equals 6. Now it's not. I don't want you to get confused here. But let's just say it was y equals 6. Then we would make all of these y's 6. Okay? So that's what we would do here. So I'm going to mark this out so we don't get confused. So forget that's even there. Eater. And let's finish this problem up. So you might be saying, if x equals 4, then what's y? Well, there's your choice. It does not matter one bit what your y is. And the reason why is because there's no y in the problem. So you can make y whatever you like because it simply doesn't matter. So we can make y 1, 2, and we can make y 207. And it does not matter. So since we only need 2 points to graph, we can graph 4, 1, and we can graph 4, 2. So here's a graph, and I do think it's important to graph this one so you can see what's unique about it. At the beginning, we saw there wasn't a y, so right off the bat, hopefully you realize that this is going to be kind of a special problem. So let's graph this. 4, 1 would be right there about, and 4, 2 would be right above it. And if we did 4, 207, it would be way up here. But what hopefully you're noticing is that it's a vertical line. Now, since it's a vertical line, I think it's important to realize what this particular line right here is never going to touch. Since it's a vertical line, think to yourself, what is this line never going to touch ever? For as long as it goes up or for as long as it goes down, what is this line never going to touch? If you said the y-axis, you're right. This line will never touch the y-axis. Most lines are going to touch both the x and the y-axis. Most diagonal lines, or all diagonal lines, will always touch both. But this one will not. And the reason why it won't touch the y-axis is because there is no y in the problem. That's why it's never going to touch the y-axis. No y in the problem, never touching the y-axis. And that's why it's a vertical line. So this is a special line. I'm curious who can answer this question. And I'll give you a second to think about it. Let me write a problem down here in the bottom right-hand corner. Y equals 6. What do you notice that's different about this problem? If you said there's no x in the problem, you're correct. Now, let's think about that. If there's no x in the problem, guess what this line's not going to touch? If you said the x-axis, you're exactly correct. And let me show you what it looks like. Since it says y equals 6, we can put a dot here. And since it's never going to touch the x-axis, we can know that this is the line. So just a little shortcut. So when you have special cases like x equals 4 and there's no y, or y equals 6 and there's no x, you can know that these special types of problems create vertical and horizontal lines. So you can now pause this this part of the homework, and you can go do homework problems number 7 through 11. When you're done with homework problem number 11, come back. Okay, if you're watching this video, then you should be halfway done with your homework assignment. This is the 5th example that we've done in your guided notes, and as you can see, it goes with homework problem 13. So this is going to be just like homework 13. So here's what they're saying. It says the graph of y equals negative 3x is shown below. So if we were to make a table like we've been practicing, and we were to graph that, then this is what it would look like. But they've already done it for us. They've already done this for us. This equation is this line. So let's continue reading. Graph the linear equation of negative 5x minus 3. So we are going to, our job is to graph this one on the same set of axes. And then we're going to talk about how the two are similar. Now right off the bat, hopefully you guys and gals notice that they are similar. They're very similar. This one's y equals negative 5x. This one starts the same way. Y equals negative 5x. The only difference is they add on this minus 3. So hopefully when you read it, you're like, hey, these are pretty similar. This one just has a little bit extra at the end. So let's see what putting this little extra at the end actually does to the problem. So here we go. Unlike the last set of problems, this one actually gives us a table for us. So if you didn't enjoy picking your own x's and y's, you don't have to worry about it on this problem because they choose them for us. So here we go. I'm going to do our first one up here. Y equals negative 5x minus 3. They give us our x. It's 0 minus 3. Y equals. Now you can do order of operations if you like. You can do multiplication first and then subtract 3. But since all the numbers are together on the right hand side of the problem, you can just do it all at once. If you'd like to type it in your calculator, do it in your head, you can. Negative 5 times 0 is 0. 0 minus 3 is negative 3. There we go. So that was quick. So we'll go negative 3. I'll erase this line so we can just do the next one below it. Let's change colors for this. Our next one, y equals negative 5. This time they tell us x is 1 minus 3. Y equals, again, you can type the whole thing in on your calculator if you'd like. Negative 5 times 1 is negative 5. Negative 5 minus 3 is negative 8. And last but not least, let's do y equals negative 5. This time they tell us x is negative 1. So throw our negative 1 in here. And we go minus 3. This time a negative and negative makes a positive. So negative 5 times negative 1 is positive 5. Positive 5 minus 3 is 2. There we go. So how many points do we need to make a line? If you said 2, you're right. I'm going to choose this one and this one because they're smaller numbers. 0, negative 3. Over 0 down to negative 3. So that's about there. And drawing points in the right spot with this program is challenging, so thank you for being patient with me. Our next one is negative 1, positive 2. So we go over negative 1, we go up to positive 2. There we go. And that's all we technically need. But to make this a little bit, just so you can see the point a little bit better, I'm going to go ahead and plot this third one. Positive 1, negative 8. So we go over positive 1, we go down to negative 8. And there we go. So I'm going to try to draw a straight line. It might be challenging, but I'm going to try my best. And that's not great, but I'll give myself a B minus. So let's talk about what these graphs seem to have in common. What they have in common, they have the same tilt. You might have remembered a word from last year. They seem to have the same slope. They're going up or they're going down at the same angle. The thing that's different is where they cross the y-axis. This one crosses right here at 0, and though you can't see it very well because my graph just isn't perfect, this one crosses at -3. So essentially, the only thing that changed is that this original line just got shifted down 3 spots. Shifted down 3 spots. So take a quick glance at the equation up there boxed in red. Is there anything about that equation that can maybe give you a hint that it gets shifted down 3 spots? If you said, hey, maybe this has something to do with it, you're exactly right. That -3 at the end means we're just going to shift it down 3 spots. The fact that our -5s were the same, that tells us that they're going to have the same angle, or more precisely the same slope. So that was a challenging problem. I'm sure you did very good with it, but that is what we have. This problem should prepare you for homework problems 12, 13, and 14. Those problems will take a little bit of time, but take your time, go slow. If you have any questions, you can come back to this video, which illustrates homework problem 13. And if you have any questions, you can raise your hand. Okay, at this point, you should be almost finished with your homework assignment. We have a couple more problems left to go, and then we should be finished. This particular problem, example 6 on your guided notes, corresponds with homework problem number 15. The last set of problems are going to be application problems. A common question students always ask is, when will this ever be used in real life? And these last few problems are a few examples of where you might see these in real life. A lot of graphing linear equations are used in the business setting. Managers of Best Buy and different places use it to predict how many items will be sold. So in this problem, it says, suppose the number of households in millions have at least one toaster can be estimated by that equation. Now, here's the important part. One of the important parts is it tells us what X represents. X is the number of years after 1999. So part A wants us to use the equation, and here's the equation. I'll write it down. Y equals 0.5x plus 92. And it wants us to complete the ordered pair. Now, as we've done for a couple days now, we get a clue. At the beginning of the lesson, we got to pick our x's and our y's, but in this problem we don't. They tell us x is 3. So we've got y equals 0.5 times 3 plus 92. Now, since everything's on the right-hand side, you guys can reach for that calculator, pick it up, and let's type this in. So you should be typing in 0.5 times 3 plus 92, and you should get 93.5. And that's the answer to A. So you'll type in 3, 93.5. So let's go to part B. So our job now is to analyze the data, to analyze what we have. So we need to pick which one of these sentences best describes what we found out. So let's take a quick glance at them. 93.5 rounds to 94, so let's use that. So in part B, they want us to analyze the data. We need to look at these sentences and we need to basically describe what we just found out. One thing you'll notice is It's talking about 94 million households. Since we have 93.5, they've just rounded up. The first example, or excuse me, the first choice A says in 2002, there were 94 million households with at least one toaster. The reason why they're saying 1992, because in the problem where I've underlined in red, it says X is the number of years after 1999. So since we use 3, 2002 is 3 years after 99. Since our answer was 93.5, it's fair to say that A is correct because we're talking about year 2002 because this is 3 years after that. And since we got 93.5, they're saying 94 million, so it rounds up to that. So in this particular problem, our best choice is B. So let's wrap this up by taking a quick glance at Part C. Part C wants us to complete the sentence below. In the year 2007, blank million households will have at least one toaster. So let's go ahead and look at our equation. Our equation is the same. We're going to go y equals 0.5x. I'm going to leave this blank for a second, plus 92. I want us to go back up here at the beginning where we talked about this. X is the number of years after 1999. So what are we going to use for our X this time? I want you to think about that. I'm going to pause for about 10 seconds, and I want you to think about what number we need to use for X if X is the number of years after 1999. If you said 8, you're right, because 2007 is 8 years after 1999. Again, since all the numerical stuff is on the right-hand side of the equation, you can pick up your calculator and you can type in with me 0.5 times 8 plus 92 equals 96 million. And this is how linear equations are used in real life settings. You can now pause this video and you can go complete problems 15. When you come back, we have one last quick example and we will be finished with this lesson. And our final problem of this lesson is example 7, which goes with homework problem number 16. It says 3 vertices of a rectangle are 3, 3, 8, 3, and 3, 5. The fourth vertices of the rectangle is. So we need to plot these points, and after you plot these 3 points, it should be easy. So the first point, 3, 3, is right there. 8, 3 over 8 up 3 is there. And finally 3, 5 over 3 up 5 is there. We're making a rectangle, so we'll connect the lines. Our missing point should be right here. So our answer would be 8, 5. Part B. Part B says find the perimeter of the rectangle. Perimeter is found by taking all of the lengths of the sides and adding them together. So here we go. This is 2 high. We can just count the blocks. That's 2. This side would be 2 because it's a rectangle. The next side is 1, 2, 3, 4, 5. So this is 5. This is 5. 2 plus 5 plus 2 plus 5 is 14, and we can put units to be specific. And that's how we find perimeter. Finally, example C says find the area of a rectangle. Area of a rectangle is probably the first formula you learned in middle school when it came to area formulas, and it is area equals length times width. So in this case, we will, again, you've heard it dozens of times, we will substitute and we will solve. So area equals 2 times 5. Area equals 10 units squared. And that's our final answer. You guys have done great. These were long notes, but we had a lot of different examples to go through. At this point, you should pause and stop this video, and you should have all the knowledge you'll need to complete this assignment. If you have any questions or if anything's confusing, don't hesitate to raise your hand, and hopefully the rest of your homework goes wonderful.